trucks or something that goes over land. So it's much more flexible to acquire this data. And finally, the sensors that we'll be using to perform this analysis and data gathering. All of them are commercial sensors that could be integrated in computer, like accelerometer, pH sensor, salinity sensor, soil moisture sensor, and even spectrometers. So you can attach this kind of sensors to our drone, and using mechanical and hydraulical systems perform this data gather. So, as a basic synthesis of our project, the timeline would be first some research of state-of-the-art research that are being developed in the area, computational area or precision agriculture area. We can say that stakeholders are universities of agriculture and automation here in Finland or in Brazil. Then explore practical examples, go to the companies that produce some kind of plant or some kind of crop that could benefit from this project and study their needs. Then develop the drone control model that would comprise first of basic flight control, like put them, turn it on, flight, move forward, move backward. Then develop advanced flight control in this period of the project. We will not using the basic flight control to send to a specified location. And finally, develop the control model that would be semi-autonomous. We just send him to a specific location. It is capable to adapt and make decisions to go over that specific location. So we can see that stakeholders here are computer science researchers, automation researchers, and companies involved in this kind of process. And finally, research and test those sensing instruments. It's very important that the measure we do with this kind of instrument to be precise and according to the measures used by precision agriculture professionals. So here again, stakeholders, precision agriculture professionals to help us to validate this data, and agronomists and engineers. And finally, produce this software to store the data and construct this kind of maps that can be useful to analyze data. Again, precision agriculture professionals, they are the main audience for this kind of product and companies interested in this project. And the last phase, integrate all models do field testing the field for all apparatus. Here we have an example of the facilities of Santa Helena Bioenergect company where we can test this project. And finally, the network that we make all these things viable. We have private sector connections, partners institutions that are working with us, our campus, IFMS Nova Andradina, UFMS in Campo Grande. They are big partners of us, providing experts and laboratories to do our tests. Private sector companies provide researchers and materials in software, hardware, and so on. Universities that I had previous contact, like USP, Escola Politécnica USP in São Paulo. They could provide knowledge in computer science, engineering, agriculture. We have very good relations with them. And general connections and research we acquired in all over the country with very specific professors, very specific persons inside companies that can be very useful for our tests and validation of the project. So that's it. If you have further questions or any kind of information, feel free to contact me at my email. We are here at Hank in Hämeenlinna, Finland, and that's my Facebook, LinkedIn, and Twitter. Feel free to contact. Thank you.